This is number 6 of the homework. So for A, it's asking us for the center of mass of the x-coordinate. For these problems, always split x and y and solve them separately if you can. So first starting with x, by definition, the center of mass is, well, where the middle of the mass is. And an important realization to make is that by definition, the center of mass, at least in the physics question, it will be exactly the same if all the mass is concentrated just in the center. So as you see here, if all the mass was just in the red dot, it would be the same. So we need to find the coordinates of the red dot. So the x-coordinate is just half of whatever this is. So this is 0.4 meters. So this x-coordinate is 0.2. This is 0.2 meters, so this x-coordinate is 0.1. This is 0.2 meters, so this x-coordinate is negative 0.1 meters. This is 0.2 meters, so this is negative 0.1. Your L may be different. My L is 10 centimeters. So you find the x-coordinate for each quadrant, for each rectangle in each quadrant. And then use the center of mass equation. But we do not know the mass, but that's okay. You can just use the area in lieu of the mass. I explain why here, but all you need to know is that you use the area. I'll explain why you don't need the mass later. So then you just take the area of the rectangle in quadrant 1 times by its x-coordinate. So take this area, then multiply it by whatever this x-coordinate is. Then take the area of all of this, multiply by its x-coordinate, take the area of all of this, multiply by its x-coordinate, take the area of all this, and multiply its x-coordinate. The area for every single one of your answers should be positive. Don't use a negative area because it's down here. You'll be using the negative x-coordinate. So then you use the formula of this, divided by the total mass, or in this case area, of all the rectangles, and then you will get your final answer. And then for B, you do the exact same process for the y-axis. You find out what the y coordinate is of the center of each one. You already know the masses of each, so you just multiply them each by their y-coordinate, whether it's positive or negative, and then divide it by the total area. Okay, so for y, you don't need the mass, and you can just use area as mass. For center of mass, it doesn't really matter the exact weight. Because like if I'm holding 2 kilograms on my right hand and 2 kilograms on my left hand, the center of mass is in the middle of me. If I hold 1,000,000 kilograms on my left hand and 1,000,000 kilograms on my right hand, the center of mass is still in the middle. So it does not matter the numbers, it only matters the ratio. And we know all the plates are uniform in density. So usually to find the weight of mass of a plate, you use the area times the density to give you the mass. But we know the density is the same, so it's a constant, and it can be ignored. So then if density can be ignored, you got area is proportional to mass. And as I said, for the center of mass, only the ratio of mass between it and the other plates matter, or only the proportion. So only the proportion matters, which means because area and mass are proportional, we can use them interchangeably.